Okay, very important. What do you mean by valency? What do you mean by valency?
Ma'am, valency, ma'am, the number of atoms present in the, the number of electrons present in the last shell of an atom.
So how we'll get this balance? Have you know about electronic configurations, children? How many?
Yes, ma'am.
Yes,
ma'am.
Yes,
Ma'am.
ma'am.
Yes,
so
ma'am.
according to which formula this electronic configuration got raised?
Distribution?
No.
Configuration itself, it's a distribution, we know. In what sense we'll distribute? Simply we'll distribute?
Ma'am,
No, ma'am.
Ma'am, you told long ago.
Yeah, I told long ago by giving different like examples. We have gone through it. See how you left the concept. That's what I want to, like, if you are not...
Months was over, ma'am, since we did chemistry.
I know, dear. So how much you remember? Tell me again. We'll go back. No need to worry. I'm not taking any pain to explain. You understood?
In the starting it was there like 2E.
Yeah, you are on track. Like two. Just remember what I said. Shall I? Or shall I give what? Half minute time for the answer.
Ma'am, I'll recollect and tell me.
Yeah.
Ma'am, repeat the question.
So in what point of view, in what way will distribute the electrons in different shells? There is one formula. The formula represents the formula used to distribute the elements in
2n square.
Excellent. Unmana or Anmana? Unmana only, no?
Yes, ma'am.
Excellent answer. It's nothing but 2n square. According to 2n square, we'll divide and we'll calculate the valency of the elements. So how did you go, or how did you calculate this 2n square? See, everything you people got forgotten. Next time I don't leave. So for every atom, I want to draw the atomic structure. Like this is the nucleus. Around the nucleus, orbitals are there. On the orbitals, these electrons will revolve, and protons and neutrons are present. So what are protons, neutrons, electrons? These three are called subatomic particles. Are you listening? Yes. These three are called subatomic particles. They are present inside the atom. The atom is very small, which cannot be divided further. That is that much small, which cannot be seen with our eye or even with the electronic microscope. That much small. So even that much small atom also consists of subatomic particles inside it. That is protons, neutrons and electrons. Protons and neutrons are present within the nucleus and electrons will revolve in a definite path. Okay? Did you recollect it? Bhavya?
Yes, ma'am.
Yes, ma'am, I recollect.
So understood. So these protons, so for every element, all these three, like what are the three? Protons, neutrons, electrons, all these three are same. For I will take carbon. If I take carbon atomic number 6, so that means the carbon consists of protons, neutrons and electrons. All the three are same. Understood? All the three are same for every element. If I go with the nitrogen, what is the number? Like atomic number 7. Atomic number 7. So how many protons are there in nitrogen? How many protons?
7.
7. Neutrons?
7.
Electrons?
7.
7.
Excuse me. So protons, neutrons, electrons, all the three are same. Understood?
Yes.
Any doubts?
No.
No? Very good. So in case of these protons, neutrons, electrons, these protons and neutrons are present within the nucleus. They won't involve in the electronic configuration or arrangement of electrons. But these electrons are present in the orbitals. So how to arrange this? How we can come to know that this is first shell, this is second, this is third, and this is fourth. Like like 7 shells will be there. Each shell is having different vacant places, empty spaces. In that empty spaces, you are going to arrange the electrons. In what basis you will arrange the electrons? For example, in the classroom, if we go into the classroom, inside the classroom, there is a particular arrangement in the classroom. Wherever we'll go, like not only here, maybe the gadgets may change, maybe the materials may change, maybe that some advanced technology got involved, but the arrangement of the classroom is same. So what is the general arrangement of the classroom? Tell me, children. Like teacher will be sitting here, at the back of the teacher, board will be there, or any other screen will be there, right? What I mean to, like in front of teacher, the benches are arranged based on the vacant places. Children will be given. Children will be given the slotting. Yes or no? Understood or not?
Yes, ma'am.
So the same way, so this arrangement is basically based on 2n square formula. This 2n square formula is given by Bohr. Who has given this formula? I think Swarthi is not writing properly. I just go ahead today. For the next coming section, I'll see that it writes good. Okay, I think it's better visual. Visually, it's okay. No problem at all for the board. So if we go with the 2n square formula, here n represents the number of the shell. N represents the number of shell, not number of electrons. Not number of electrons. Here n is equal to number of the shell. Like if it is first shell, you represent that 1 in place of n. Just substitute 1. So first shell can accommodate 2. Second shell also can accommodate. These are nothing but vacant places.
Ma'am, 8, ma'am.
So second shell, 8. Third shell,
16.
Fourth shell, 16. 9 2s are how much? 18, no? You are saying I'm writing. 32. Like that, 7 shells are there, so that you can calculate according to 2n square formula given by Bohr. So by writing the shells, we can come to know that first shell can have how many vacant places in the first shell? 2. Second shell?
The shell will be 40. The fifth shell will be 62. I mean 64.
Yes, but there are some drawbacks about this arrangement. I'll tell you the drawbacks. So, it's like 2, 8, 18, 32, like that. So, leave about 4 shells. Don't go beyond the 4 shells. There are some drawbacks about it. So, we'll discuss it now. So, according to 2n square formula, we can come to know that first shell, that means first bench, considered as a first bench. First bench means first bench can accommodate 2 children. Second shell, consider second shell as second bench. So, second bench can accommodate 8 children. Understood? Here, who are the children?
Electrons.
Electrons are nothing but children. How we are arranging children in the classroom, at the same way, we are arranging electrons in different shells according to the vacant places. Any doubts? So according to 2n square formula, 2, 8, 18, 18, 32. But there are some drawbacks which were corrected by the same scientist, and he has given some other electronic configuration based on the drawback. So it's not like a bigger drawback. Here we can see that 2, 8 and third shell 18 electrons. It can accommodate how many electrons?
18.
18 electrons. It can accommodate 18 electrons. But the third shell cannot bear all the 18 electrons. If all the 18 electrons are occupied their places, the orbital, the shell cannot bear. The shell feels like stress, pressurized. So it can't bear.
Yes, ma'am.
So in that point of view, the same scientist, Bohr itself, has given, based on the arrangement of periodic table, this you are going to learn in your higher class, based on the periodic table, he has given one more order like 2, 8, 8, 18, 18, 32, 32. Understood? Is it visible? Is it visible? He has given one more this thing based upon 2, 8, 8, 18, 18, 32, 32. Like first write 2. After that repeat 2 times 8, repeat 18 2 times and repeat 32 2 times. Total 7 shells. Understood?
Yes, ma'am. Ma'am, you're muted.
Okay. Here 2, 8, 8, 18, 18, 32, 32. So that means third shell can accommodate how many electrons?
8.
Only 8, not beyond that. It cannot bear more than 8. It can bear up to 8. The same scientist has given this idea also to give. Okay. So now just arrange it based upon this configuration. For example, I'm writing sodium. Atomic number of sodium 11. I want to arrange in differentials. First write down the vacant places in differentials. Like what is the order 2? What is the order, children?
2, 8, 8, 18, 18, 32, 32.
Yes. 2, 8, 8, 18, 18, 32, 32. Understood? So based on this, so that now I can arrange. So 11 electrons are there with sodium. So I want to arrange all the 11 electrons in differentials. First shell 2 I'll arrange. I'll arrange 2. So remaining after filling the first, second shell 8. 2 plus 8, 10. So one more is left. Though it is having 8 places, but only one electron is there. One will be there. Leave about the places.
Ma'am, so the one. Ma'am, 281.
281. Electronic.
Ma'am, so the valency will be 1.
Yeah, I'll explain. So this is called the last shell. Last shell is known as valency shell, or it is also called as the electrons which are present in the last shell is called valence electrons. So how many electrons it is donating, how many electrons it is accepting, it is mainly based upon the valency electrons. So if the valency electrons below 5 or 4, till 4, the valency electrons till 4, it donates, it gives. When it gives, how many electrons are present in the outer shell? 8. Then it is stable according to inert gas configuration. What do you mean by inert gas configuration? Helium 2.
Which complete the octet rule.
Yes, which completes the duplet and octet rules. Yes. Which completes the duplet or octet rule. That means the outermost shell consists of 2 or 8 or 18 or 32. Completely filled. So that they won't give and they won't take to get the stability. Okay, understood? So here 281 is there. So one is below 5 or below 4. So it is ability to donate. When it donates 1, so it is having 8 in its outermost shell. So it is stable.
Yes, ma'am.
So what do you mean by balance? How many it is donating, how many it is accepting? No matter of the remaining remaining electrons, only we considered how many it is donating, how many it is accepting. So how many it is donating?
1.
So valency of sodium is 1.
Yes, ma'am.
Understood?
Yes, ma'am.
So shall I show you a video? Shall I show you the video? And we'll go in brief.
Okay.
Okay. 1 minute. I think one more session required for this, and again few more concepts I'm going to add. Okay. So I'm going to mute myself. Just go through the table. Okay.
Ma'am, I took a picture of it. I took a screenshot of it. Is it fine? Okay. Ma'am, I didn't understand. What is this table basically about?
Just go through the video so that again I'm going to explain it. Okay. I'm just offing or muting myself so that it won't be. Bhavya, I think you have asked or someone asked me about what do you mean by octet or duplet? It is
No, ma'am.
Who asked me? Arna? Someone? Okay.
Ma'am, I didn't ask.
So someone asked me, okay, Lee, this is because of the stable configuration. When we go with argon and neon, see the outermost shells are completely filled with 8. 8 means octet. Octopus. What do you mean by octopus? Octopus means the animal with the 8 arms. Understood? So the same way, 8, the outer shell should be like 2. If it is completely filled 2, then it is duplet. According to duplet, it is stable. If it is completely filled with 8, then it is said to be octet. So any element by giving or by taking the electrons, it should have 8 electrons in its outermost shell. By giving the last electrons, the previous electron should have 8. Understood?
Yes.
So by giving and by taking the electrons, it should get stability according to the inert gas configurations like helium, neon, argon, krypton, xenon, all this. All these are very much stable. They won't give, they won't take. Until and unless they won't give, they won't take. That means they're stable. They won't combine only. They'll be stable even in the atmosphere also. Helium gas is like helium only, He only. It won't combine like another helium also. It will be like He. Any doubts?
No, ma'am.
Yeah, very good. Just follow the before also have.
Ma'am, you're muted.
Yeah. Okay. Any doubts about it?
No, ma'am. No, ma'am.
No, I think you are very much understood about the valence. Valence is nothing but combining capacity. In the classroom, if you sit alone in the classroom without mingling with anyone or without sharing, or when they are sharing, if you won't accept, understood? If your friends are there, when you open your break, you definitely share. So if your friend takes happily what you have given, then definitely there is a formation of bond between you and your friend. If you wants to give the food to her, and if she is not accepting, then what you will feel? For the next time you won't give, you won't share, because she is not willing to take. At the same way, when she gives, you are able to take. Then only she'll feel like you are her best friend. Understood? So by giving and by taking, so that there is a formation of bond and the element itself will become stable. Understood? So there are monovalent, divalent or trivalent. If the elements share only one electron, then it comes under mono. Mono means one. With valency 1, like sodium 1, hydrogen 1, chlorine 1. They may be take or they may be give. Divalent means valency 2, oxygen. Trivalent means oxygen 3, valency 3. Tetravalent means valency. Understood?
Yes.
Understood or not? So no doubts.
No.
So they may be valency, variable valencies based on like same element can be having two different valencies or more than two different valencies. So according to the formation of bond, according to the situation, according to the adjacent element which it wants to combine, then the valency may change. Iron is having two valencies, that is valency 2 and valency 3. Based on the different valencies they combine. Understood? So these are nothing but variable valencies. Any doubts?
No.
No doubts.
No, ma'am.
Next, compound radicals. What do you mean by radicals? Compound radicals. So for example,
Ma'am, can I tell what radicals are?
yeah, you can.
Yes, ma'am. Ma'am, radicals are it is like they are the molecules that contain at least one unpaired electron. Like most molecules contain even numbers of electrons, and the covalent chemical bonds holding the atoms together within a molecule normally consist of pairs of electrons jointly shared.
Can you please give me the example for the radical?
Ma'am, what example?
Ma'am, ammonium?
Very good. Very good. Priscilla, very good. Ammonium is a radical. Hydrogen carbonate is a radical. Simply carbon is a radical. Sulfate is a radical. So there are
Ma'am,
different
bisulfate is a bisulfate, no, ma'am.
Sulfate. Okay. Carbonate. Hydrogen carbonate. Phosphate. Ammonium. Understood?
Ma'am,
Hydroxy. Okay, these are the different radicals. These radicals are nothing but radical is nothing but a group of elements combined and gives only one valency. If we go sulfate valency is 2, carbonate valency 2, all together. Hydrogen carbonate is 1, phosphate 2, ammonia is 1, and hydroxide is 1. So a group of elements combines with the other element, or with the other metal to form compound. So within that compound, if they combine with sodium is a metal. When it combines with sodium, it says that sodium carbonate, bicarbonate. This entire bicarbonate shows one valency. Understood? That is called radical. Like when we see about ammonium, NH4, the entire NH4 shares the valency 1. That's why we represent the radical in the brackets. Understood? Understood or not?
Yes, ma'am.
So we represent the radicals in the boxes. Okay, no doubts, no? That is called compound radical. Next important concept, chemical equations. How to represent chemical equation? How to represent chemical equation. So we know that any reaction which we have done in the laboratory, or if anybody, any scientist worked on the chemical reaction, which worked in the laboratory or industrially, so that will be represented. We can't go and see all the chemicals now. When they represent the reaction on paper or any other screen or anywhere or based by using symbols, it's nothing but chemical equation. Understood or not? It's a proved chemical reaction which is presented by using formulas or by using symbols. It's nothing but chemical equation. Understood? So when we discuss about carbon dioxide, how carbon dioxide formed? When carbon reacts in the atmosphere itself, it won't come by like doing wantedly. Simultaneous process. It's spontaneous process. It does by their own. It completes by its own. Like C plus O2 gives rise to CO2. This carbon in the atmosphere combined with the oxygen gas to form carbon dioxide. When this carbon burns, especially when you burn the paper, when the paper burns in presence of oxygen, there is a release of carbon dioxide. How the reaction takes place, how we'll come to know about it by representing by using different formulas and symbols. That is nothing but chemical equation. Understood? How to represent a chemical equation? So towards the left, when we see towards the lefts are reactants, the chemicals which you know. So when I want to cook a dish, the ingredients, all the ingredients I know or I don't know.
Ma'am, you should know.
And product is secondary. We know the ingredients, no? So when we take the ingredients which are required, by seeing the ingredients, we can come to know an idea about the product. Yes or no?
Yes.
Yes. So if I want to bake a cake, the sugar and flour, and if it is egg with egg, so eggs will be added, essence will be added. By seeing the ingredients, you'll come to know that it's a bakery item, especially it's nothing but a cake. So at the same way, when carbon reacts with oxygen gas to form carbon dioxide, final product you'll come to know, you will get the product. That product should be written towards the right. Left reactants, products right. And this arrow mark represents the direction of the reaction.
Ma'am, it also represents the phrase gives rise to.
It's nothing but towards the product. It shows towards the product after completing the reaction. This plus sign represents how many number of reactants. Plus sign represents how many number of reactants. If the product side also plus are there, means these many products got obtained when this reaction carried on or carried on.
Ma'am, can we say that about the plus sign, which is there to the left side, can we say like, for example, here only C plus O2 means like C is added to O2.
Yes, C burns in presence of O2 or C presence of O2. C is reacting with O2. C is nothing but carbon here.
Okay.
So what do you mean by balancing of equation?
Ma'am, like if an equation is there, we should maintain the balance or the same number of atoms of an element on the product side and the reactant side.
So that means both reactants and the products, should be equal. Then only we can say balancing of equation. So especially when we go with the balancing of equation, 1 minute, I just show you a nice video about the balancing of equation. You want to see?
Ma'am, but we have very less time left.
Yes, no problem. Leave about the time.
Yes, ma'am.
No problem about the time. If you want to see, again, simultaneously explanation part is going on. If you'll see that, no problem. We'll go 2 minutes extra. What is there and there?
Okay. Ma'am, you're muted.
Consider this tug of war is nothing but left side are reactants and right side products. At the same time, when we go to the market, have you seen the pans with the pointer at the center? Have you seen the pans with the pointer at the center?
In the school already.
Yeah, yeah. Even though, just go through it. What is there?
Okay.
According to which law, children, this balancing of equation takes place? According to the law of conservation of
matter.
Yes, mass neither be created nor be destroyed.